Good morning, everyone. Welcome to day 2 of MWise. My name is Matt, and along with Chris in the back row there with his hand raised, we're the room facilitators for the cloud security track. If you have any questions or need anything throughout the next day and a half, please let us know. A couple housekeeping items before I introduce our two speakers for this morning. Number one is lunch is at 12:15 today. There are also lunch and learn sessions that you can see in your app. Those are first come, first serve with lunch in the room. We also have our keynote speaker today, Jane McGonigal. She's an author, game designer, and researcher. She'll be signing books in the expo floor starting at 12:15 today. So I encourage you to stop by. You can pick up a copy of the book and she will sign it. In addition, if you're registered for the Elevate Luncheon, that's taking place at 12:15 to 1:45 today in the Shaw Room on level M3. And a reminder, as I always do on surveys, they'll be available in the app. That's the pencil icon if you can't find it in the app on the bottom right. That's where you can complete surveys. If you complete 6 of them, you can pick up a free swag gift in the expo floor. And they'll be available 15 minutes after the session is over. Without any further ado, I'll introduce our first speakers for today, and it's Will and Omar.
Thank you, Matthew. Thank you. Morning, folks. Thank you for joining us, and welcome to Bridging the Gap between on-prem and cloud security. I'll start with a quick intro. My name is Omar Lahdan.
My name is Will Silverstone.
And we're both part of the Mandiant Security Transformation Services team, or SCS for short. At SCS, we spend about 50% of our time performing incident response remediation, meaning we go in to contain, posture, and eradicate threat actors from on-prem and cloud environments during cyber incidents. The other 50% of our time, we spend it performing proactive engagements, such as on-prem and cloud security assessments.
So we'll start off with just a quick agenda of what we'll cover off on today. We'll essentially break down the session into 3 kind of main areas of focus that we see attackers taking advantage of as it relates to kind of cloud compromise. And then we'll go through some incident response examples and case studies that our team has responded to. And then we'll wrap up with some takeaways and recommendations that can hopefully help your teams secure your environment. So kind of using these next 2 stats to set the stage in terms of when we think about cloud security and cloud compromise, we don't want to just think about cloud in isolation, in that 99% of organizations are running some sort of hybrid infrastructure, being cloud and on-prem. And so at the same time, 63% of organizations are 63% of organizations are using either most of the same or exactly the same approach for securing their cloud environment as they are for their on-premise environment. And so that's where we kind of want to focus the session here today, in that we don't want to just treat cloud security in a silo or in isolation, but we also don't want to just kind of lift and shift our security approach from on-premise to cloud. And so our security approach when it comes to protecting cloud environments should account for the fact that lines between on-premise and cloud environments are interconnected and blurred and overlapping. There's an increasing importance of protecting identities, with identities being kind of that security boundary for cloud environments. And then there's an extended attack surface that includes your on-premise networks, it includes cloud, and kind of everything in between.
Awesome. And we wanted to bring the frontline experience of how we actually see threat actors exploit and abuse and compromise cloud environments. We broke it down for the purpose of this session into 3 main pillars. Pillar 1, understanding your hybrid architecture. Throughout this pillar, we'll touch on how threat actors exploit and abuse connectivity and integrations between your on-prem and cloud environments. Pillar 2, around identities. Over here, we'll touch on how threat actors exploit weak identity controls. And we'll also touch on often overlooked aspects to identity, as well as multi-factor authentication. And our last pillar, we'll touch on an attack surface and why we need to change the narrative or the perspective when looking at our attack surface to not just encompass the network and public accessibility, but also to encompass identity as part of our attack surface. I want to spend 30 seconds to give a quick overview of how Mandiant tracks and identifies threat actors. Mandiant categorizes threat actors in one of 3 buckets. Bucket 1 is APT. An APT threat actor, those are nation-state-sponsored threat actors, highly technical in nature. Bucket 2 is FIN, financially motivated threat actors. And last bucket is UNC, or uncategorized. And every threat actor that we start tracking falls under that UNC group, and they could graduate to either FIN or an APT, but it's a long and complex process. The last piece to that is throughout our session today, we'll reference threat actors by saying TA. We'll go through numerous case studies and IR examples. We had to modify some of the data and the facts to protect our clients, as well as the identity of individuals associated with our clients. And with that, I'll hand it over to Will to kick us off on our first pillar, understanding your hybrid architecture.
Awesome, thanks. Yeah, so to get started, we'll go through some kind of common challenges that we're seeing organizations face as it relates to this kind of hybrid environment. Starting off with protecting and securing that tier 0 infrastructure within the cloud. And so what we're seeing on our incident response engagements and our proactive assessments are that organizations are deploying that kind of tier 0 infrastructure, think Active Directory domain controllers, PAM servers, PKI servers, into their cloud environments. And so when you deploy that critical infrastructure that can control your on-premise environment into your cloud environment, the security of your on-prem and cloud environments are now tied to one another. So misconfiguration or compromise on-prem can endanger the security of your cloud environment, and vice versa. And so that kind of leads into the second point in terms of accounting for privilege escalation and lateral movement between cloud and on-premise environments, in that a compromise of one environment can lead an attacker to get a foothold into the cloud environment, or vice versa. And then lastly, accounting for the control plane and the data plane as it relates to cloud environments specifically. The control plane being that kind of administrative function of cloud environments. Think the cloud console or APIs to create, update, delete resources. And then the data plane being that running infrastructure itself. And so as security teams tasked with protecting cloud environments, we need to think about protecting access controls and security controls at both that control plane level and also the data plane level as well. And so we'll get into an example of that. So here we're just kind of showing a kind of typical cloud resource hierarchy, Azure management groups, GCP folders, AWS organizations with projects, subscriptions, accounts within those, and then the actual infrastructure below that. And so like we mentioned, we're seeing kind of organizations deploying that tier 0 infrastructure within their cloud environments as virtual machines and a certain subscription within a certain management group, things like that. And so organizations are deploying that tier 0 critical infrastructure down at these levels in the hierarchy without necessarily thinking about the security controls or access controls that have been applied at higher levels in that hierarchy. So if you take, for example, a GCP project that has a domain controller running as a virtual machine at kind of lower levels in the hierarchy, and you have a compute instance admin role that's been assigned at a folder level in that hierarchy, that cloud administrator who's assigned that role can now reset passwords on that domain controller, create local administrator accounts on the domain controller. And so you could imagine a scenario where a compromise of that cloud administrator account can then lead to a compromise of the on-premise Active Directory. And so that's kind of a way that a compromise of a cloud environment could lead to compromise of the on-prem. We'll get into our first incident response case study here. That kind of shows the reverse in terms of how on-premise compromise could then lead to, in this case, ransomware in a cloud environment. And so what we saw in this specific example was an on-premise Exchange server, publicly exposed, ended up being compromised from a specific vulnerability. Attacker was able to exfiltrate emails, certain data outside this organization. And in this specific case, they sold that data and emails to a second UNC group, who was then able to use those stolen emails as a lure and as a targeted phishing campaign towards a specific set of users. And because that data was coming from specific emails about the organization, the number of users fell for the phishing emails. Eventually, the attacker was able to compromise a number of highly privileged accounts, get onto the VPN, move laterally to a domain controller, and have the privileges to deploy GPOs within that environment. And so eventually, the attacker created a GPO that deployed that ransomware across the domain. And in this specific environment, the client had virtual machines that were deployed in their cloud environment that were domain joined and had no segmentation between the cloud and on-premise environments. And so there was nothing stopping that ransomware GPO from moving from the on-premise environment to the virtual machines that were deployed in the cloud. And so when we think about ransomware in the cloud, this is often the kind of scenario that we think about in terms of there's very often an on-premise component that's included in that. So we'll get into kind of the takeaways from this. And we'll break it down into kind of two areas. The first one being just securing that tier 0 infrastructure like we talked about. First bullet point here being considering that permissions inheritance. So really understanding the full picture of who has access to your critical resources that are deployed in the cloud, both from the control plane and also from the data plane perspective. And one way to do that would be using dedicated folders or dedicated management groups for that tier 0 infrastructure to reduce the security controls or access controls that are getting inherited down to those. And then if you're using some sort of tiering model within your on-premise Active Directory to align that most critical infrastructure to more stringent security controls, making sure that's somehow reflected within your deployment within the cloud. So maybe that's more granular logging associated with it, more strict access controls, things like that. And then the second piece around properly segmenting that cloud and on-premise environment. So thinking the on-premise security best practices still apply within cloud environments. So restricting outbound network connections using things like AWS security groups or cloud firewall to restrict outbound connection where it's not required. Things that, if we think about that ransomware scenario, would prevent ransomware from spreading from on-premise into the cloud, but also within that cloud environment. So making sure that you're using the kind of firewalls afforded to you within the cloud to properly segment that environment. And then lastly, if you're responsible for protecting and securing a cloud environment yourself, making sure you're understanding how your cloud and on-premise environments are interconnected so you understand those lateral movement paths and privilege escalation paths that can allow an on-premise compromise to then lead to a compromise within your cloud environment. And then we'll finish off this section with some kind of logging and detection priorities. First off, those control plane audit logs that kind of show what's happening from the administration side of the cloud environment. So thinking, those AWS CloudTrail logs, Google audit logs, Azure Activity. These are generally enabled by default. The piece that, generally when we go into incident response engagements, the logs that are required to do a full investigation haven't necessarily been enabled by default and need to be enabled and configured by the organization ahead of time. So these are things like firewall logs, compute and database logs, data access logs of what's going on within a specific database. And so, having these data plane logins data plane level logging can be very valuable, both from a detection and a incident response investigation perspective. And then lastly, thinking about correlation opportunities between your on-premise logs and your cloud logs, so that if you have that scenario where an on-premise account is compromised, that moves to AWS, for example, where activity is done on a certain database, that we have the logs to be able to correlate, alert, and detect on movement from that on-premise Active Directory logs to those cloud control plane logs to those data plane level logs to get the full picture of what's going on across both environments. And so with that, I'll pass it back over to Omar to go into the second section.
Awesome. Thank you, Will. And before we dig into my second pillar around identity, let's start with an interesting statistic. Within 2023, Q1 of 2023, more than 60% of cloud incidents originated from some sort of an identity compromise, such as the brute force of an account with weak or no password, leaked credentials, or even phishing attacks. So what are the common challenges as it relates to identity that we see threat actors exploit?
You said that was 60%?
Yeah, more than 60%. Common challenge number one is the lack of identity tiering and separation. We oftentimes see organizations using their on-prem IDP, commonly Active Directory, to manage and administer their on-prem as well as their cloud environment. And oftentimes, that IDP or Active Directory is built on legacy architecture, legacy setup, and what that creates is a massive risk vector, where right now, on-prem identities, when and if compromised, threat actors are able to use those identities to log in directly to cloud environments. Challenge number 2, an excessive scope of privileged identities. A lot of organizations have moved fast to the cloud. They've migrated critical workloads and assets to the cloud. And for the purpose of ease of use, they just started using the default roles across the cloud service providers. And even worse, we see them handing over those default roles to their infrastructure and to their DevOps teams. In AWS, we see an excessive use of the administrator role. In Azure, we see an excessive use of the global administrator role. And in GCP, we still see organizations using basic roles, such as editor, for example. And when you look at the editor role, you'll see it has more than 4,000 overlapping and highly permissive permissions across that role. The third common challenge is around weak multi-factor authentication, enforcement, registration, and visibility. When it comes to MFA, there's 2 pieces to it. One is the MFA method that's actually being enforced, and we'll touch on that later. But the second piece, which is oftentimes overlooked by our organizations, is the operational aspect of multi-factor authentication. How many users, from where users can register devices, how many devices can a single user use, etc. Let's walk through our first IR case study in that pillar, where we'll see how a threat actor is exploiting some of those challenges. In this case, we have an APT group. And as a reminder, we said earlier, APT, they're nation-state sponsored threat actors and highly technical in nature. In this case, they use stolen credentials to log into a single-factor VPN. Once they accessed the VPN, they started accessing a bunch of systems that are hosted on-prem, and as they were accessing those systems, they were installing RATs, or remote access tools. This is a common mechanism used by threat actors to maintain persistence within an infrastructure. They were able to eventually get to a domain controller that's hosted on-prem, and what they did then is they dumped and exfiltrated the Active Directory database, also known as the ntds.dit. What's interesting, though, is the next step the threat actor took, where they came back after 24 hours using credentials that they've compromised from the Active Directory database they had exfiltrated, and they logged in directly into Azure Active Directory. Once they logged into Azure Active Directory, they spent some time performing reconnaissance to really understand the lay of the land, understand the different security configs within Azure AD, and eventually they started modifying some of those settings. And then their last step was to exfiltrate highly sensitive folders and data set from SharePoint. So what are the key takeaways from this IR example? One is the use of distinct and segregated accounts for cloud administration. Cloud privileged accounts should not be synced, should not be managed within your on-prem IDP. Those should be isolated and maintained only within the cloud. An administrator account should only be used for administrative functions. It should be separate than a daily driver account. A daily driver is an account that's used by every end user to access email, do their day-to-day job. 2, the implementation of just-in-time check-in, check-out access model with access approval, meaning that, yes, we have privileged identities, but they're only privileged for a finite duration of time. They're not privileged off hours. They're not privileged on PTO or on weekends. They are only privileged when they have to perform administrative functions. And to even elevate their access, they have to go through an access approval process where a secondary admin or a team lead has to approve the elevation request. Right now, we see that most cloud service providers offer some sort of a privileged identity management functionality that provides you that capability. But we also see organizations successfully deploying a PAM solution, privileged access management solution, that also provides that capability. The third takeaway is to consider using some sort of a privileged access workstations. There's many ways to install and configure a successfully implemented PAW, but the real benefit of a PAW is that it introduces a barrier between your everyday endpoints being compromised and administrative endpoints. A successfully implemented PAW should be isolated, should be segmented, with limited access to the internet. One common technique when deploying a PAW is to restrict access to your administrative consoles, to your cloud consoles, to and from the PAW. And the benefit of that is that even if the administrative credentials or account are compromised by a threat actor, The paw adds an additional barrier because they would still have to compromise the paw in order to access the console or the administrative portal. And lastly, the use of a multi-admin approval capability. Right now, a lot of vendors, as well as cloud service providers, offer some sort of a multi-admin approval capability, meaning that not one admin can deploy massive change, conduct massive configuration change. One admin can initiate it, but a secondary admin has to approve that request and kick it off or deploy it across the infrastructure. In Azure, we see Microsoft deploying a multi-admin approval functionality with Intune. At Google, we announced Workspace, multi-admin approval capability within Workspace that will come out at the end of this year. But even if the vendor or cloud provider is not providing a multi-admin approval functionality, the benefit of cloud and the ease of use of modifying roles could allow you to define and implement a multi-admin approval structure using cloud IAM roles. And now, we talked a lot about identity. Let's shift gears and talk through multi-factor authentication. There's two main MFA attack techniques that we see out there, and we see a lot of threat actors exploiting that I want to touch on here. First one is MFA fatigue. MFA fatigue, it's an attack technique used by ONC, APT, and FIN threat actors, whereas they send users a ton of MFA requests on their phone. Users don't know what to do. Threat actors are exploiting the fact that end users, one, do not know what to do. Two, they're frustrated. They want their phone to stop buzzing. So they end up accepting an MFA prompt or MFA request, granting the threat actor access. Still commonly used as an attack technique, especially across organizations that are using still push notification. The second attack technique is AITM, or adversary in the middle. And this attack technique is a little bit more interesting, where, again, we're seeing it used by APT, FIN, and UNC groups. But what we see them do is register domains that look and feel like your organization domain, say your organization name -sso.com, and then target users with emails or even SMS messages that include a link that, again, looks and feels as if it's coming from your organization. And once a user clicks on it, it prompts them to a portal where they have to go through authentication, enter their username, enter their password, and then they're challenged for multi-factor authentication. And once they enter all of the details, that grants the threat actor access because all that data set goes back to the threat actor's infrastructure. Not all MFA methods are vulnerable for those attacks, though. Let's talk through some of the commonly used MFA methods that we see organizations use and talk through specifically ones that are still vulnerable for those attack techniques. I'm bucketing these two together as email, SMS, phone call, and push, commonly used by organizations. Those are pretty much vulnerable to the same attack methods or attack techniques, such as SIM swaps, adversary in the middle, MFA fatigue, for example. And because of that, we saw vendors move towards time-based one-time passcodes, where end users would install some sort of an application on their phone, and they'd have to enter a 6-digit code that's randomly generated every 60 seconds, for example. That MFA method provides an additional layer of security, much more secure than SMS and email. Yet again, we're seeing that with successful social engineering campaigns, end users fall for it and end up providing threat actors the 6-digit MFA code. And because of that, we saw vendors move to context matching. And with context matching, you're enabling the user by providing them additional data set to allow them to determine what the legitimacy of that MFA request. That additional data set can be the application they're attempting to log into, the IP address, or even the location they're trying to access from. But yet again, with successful social engineering campaigns, end users fall for it, end up granting the threat actor access. And because of that, we saw a move to phishing-resistant MFA methods, such as FIDO, for example. And FIDO, as an MFA method, it provides enhanced security over all those other MFA methods. It's resilient to the common MFA attack techniques that we talked about. Yet, from an operational perspective, it becomes much, much more difficult to deploy and scale FIDO, given that you need to physically ship hardware keys to your end users. It's even worse if you're a global organization. Much more painful, requires additional time, planning, costs, etc. So what do we do to protect our organization when it comes to MFA. One is enforcing phishing-resistant MFA. This is obvious, like FIDO. But yet again, if we cannot enforce it on all users, that's totally fine. Let's at least focus on privileged identities as well as high-value users, users that would be targeted by threat actors. Two is let's look at the MFA operational aspect and think about how are end users registering their MFA devices from where? Let's restrict it where they have to be in a physically trusted network location in order to conduct any MFA changes, such as coming to an office to register or deregister or change a phone number for MFA. Or a second option can be that they have to go through the help desk, go through a video verification process, physically present their ID, and once they pass that, they're granted that ability to register or change their MFA method. Number three is detect, alert, and react upon all MFA method changes. Any changes should be detected as it relates to MFA and should be reacted upon by the help desk as well as your security teams. MFA addition, removal, phone number change, whatever it is, that should be detected and alerted upon. And lastly, from an endpoint perspective, enforcing some additional constraints to protect against some MFA attack techniques, such as session relay, for example, where an attacker compromises an endpoint, uses some of the tokens and sessions on that endpoint, puts it on their VM or the attacker endpoint, and then is able to access whatever that end user has access to. And to protect against that attack technique, we can require our endpoints to access resources and workloads as well as cloud consoles to be compliant with your policies. They have your security stack. They have your EDR tools. Two, they're joined to your domain. And then lastly, we're enforcing some sort of a session reduction. So we're not going with the default session livelihood of 90 days, 120 days, for example. And with that, I'll hand it back to Will to go over our third pillar, reducing your attack surface.
Awesome. So for the third pillar around attack surface, we'll start off with common challenges similar to the other two. Kind of main things that we want to cover off here is kind of having the ability to see your own environment as attackers can. And the other kind of main challenge that we see organizations face is that attack surface isn't just network related, especially in cloud environments. That being said, publicly exposed resources still a very common cause of compromise within cloud environments. And we'll get into some incident response case studies of how we're seeing these misconfigured and continue to occur. Tenant enumeration as an attack surface method, really having the understanding of the identities, the security configurations, the resource configurations, the things that if an attacker gets maybe read-only or low-privileged access within your environment, things that can be enumerated about those tenant configurations. And then lastly, we're including that kind of sprawl of keys and credentials as part of attack surface here. Things like long-lived service account credentials, user credentials that can be exposed within public code repositories, Google Drive folder, SharePoint sites, any kind of insecure location like that. And then we'll get into some incident response case studies of how we're seeing those get compromised. So we'll go through each of those, starting off with publicly exposed resources. And this is probably the one when you think about headlines or news about cloud compromise. This is the one that probably comes up more often in terms of a publicly exposed S3 bucket that's holding highly sensitive data. An attacker is able to scan for that, identify it, and maybe exfiltrate the data outside the organization. And so cloud providers have done a lot over the years to make it more difficult to configure these insecurely, but it's still an issue that we see kind of worth bringing up, both in terms of the infrastructure as a service, usually virtual machines that have network settings configured incorrectly to allow public access, and also from the platform as a service, those database services, those storage accounts, Kubernetes services, where sometimes it's a single configuration or setting that can allow a specific resource to be exposed to the public. And so the next incident response case study will kind of go through how we're seeing that continue to occur. In this case, we had an organization deploying a build server as a virtual machine within their cloud environment. In this case, they obviously wanted it to be restricted only to their data center IP addresses to be able to access it. So they put it behind a reverse proxy virtual machine. That reverse proxy only accepts connections from the data center IP, and the build server with highly sensitive data has a security group attached that you can see that's only accepting connections from that one virtual machine. During the course of setting this up, they attached, there we go. Oops, is that not going?
No, you have to come closer here, I think.
Ah, okay, awesome. Yeah, so they attached Elastic IP onto that virtual machine, and then over the course of days or weeks after setting this up, an administrator, maybe working from home or somewhere outside the data center IP, attaches a new security group rule that allows access from the internet just temporarily for his own purpose. And so now this virtual machine build server has an Elastic IP, public IP address, and a security group rule that's allowing access from the internet. And so what we see is attackers continuously scanning for these type of resources. And in this specific case, we had an UNC group that was able to scan for, identify this virtual machine, brute force their way onto it, and then eventually exfiltrate that highly sensitive data that was held on that virtual machine and use it to extort this specific organization. And so takeaways from that, kind of thinking about some different areas, starting off with that cloud security posture management, obviously has a lot of value when we think about cloud security. The one that we're focused on here is from an inventory perspective. So really having an understanding of what should be exposed to the public, and then having the ability to detect and remediate on anything that falls out of compliance with that. And so a CSPM tool is a great way to kind of identify those misconfigurations. Another one would be around, oops, I'm on the wrong slide here, sorry. Well, the other piece is around external attack surface management. So, having the ability to detect, from a public IP perspective, what resources are exposed to the public, what software is running on them, any vulnerabilities, things like that. And so there's a lot of kind of tools that attackers and our own red teams use to help to identify these publicly facing resources, both from the perspective of public exposure, but also from that identity and tenant enumeration. Tools that can help to, if an attacker does have read-only access within your environment, enumerate data about what's held within that resource configurations, identities, things like that. Yeah, so like I mentioned, there's the cloud security posture management, external attack surface management. The other piece that aren't as network related would be things like social media and dark web scanning for keys and credentials or targeted keywords about your organization. Things like Omar mentioned, domain name registrations that may be similar to your organization domain, having a process to take those down as well. And then secrets and credential scanning, in those public code repositories and file shares, looking for different insecure locations where keys and credentials might be stored, but also within cloud environments themselves. Think Lambda function variables, infrastructure as code templates, virtual machine startup scripts. These are all the kind of areas that if attacker gets access, say, to an AWS account and has read-only access, they start scanning for these credentials as a way to look to escalate privileges within that. And so on that point of scanning for credentials, we get into our last incident response case study here around a service account credential that led to crypto mining within a specific cloud environment. Here we had a GCP service account created, had owner permissions attached, and so we'll get into the takeaways after this about over-permissive service accounts. But in this specific case, that service account had a credential associated with it, a private key that was eventually inadvertently published to a public code repository. And so for this organization, they had GCP Security Command Center running. It was able to identify within 2 minutes that that key had been exposed to a specific code repository, had these permissions attached, and so it set off an alert. Unfortunately for this organization, they weren't actively monitoring their Security Command Center alerts, and so an attacker was able to identify this specific credential. They were able to set up internet connectivity within a number of regions within the GCP project, and they were able to spin up virtual machines, deploy crypto mining software, and go from there. And so eventually what set off this particular organization was not the Security Command Center alert, but it was the unexpectedly high cost anomaly for the regions and projects that they were in scope for this. And so just finishing off with a few takeaways for kind of protecting service accounts, protecting those credentials. Starting off with determining and identifying where we can start to get rid of those long-lived credentials. Thinking about in AWS using roles instead of long-term access keys with users, using in Azure like managed identities, GCP using workload identity federation instead of service accounts, things like that. If those service account long-term credentials are required, making sure that we have an inventory of how they're being used, who the owners are. So in the case of compromise, we have a clear inventory of what the dependencies associated with that service account are, if it does need to be rotated. Limiting the scope of service accounts, so this is a pretty clear one from the incident response example, but also kind of in general. This is one that's often easier said than done, but we see a lot of value in reducing the impact, especially in those incident response engagements. And then lastly, monitoring for exposed keys, making sure that we're using those kind of out-of-the-box detections that come from the certain cloud providers, that come from third-party services to be able to detect and alert on anomalies with service accounts, and then maybe building custom detections for our specific environment. If we know a key should be used in this specific way, can we alert and detect on anything outside of that? And then lastly, having processes and runbooks for if a key is determined to be compromised, how are we going to rotate that, who needs to be looped in, and having a full process to remediate that. And so with that, I'll pass it back over to Omar to wrap us up.
Awesome. Thank you, Will. Right, folks, let's wrap up. So we talked through three major pillars. Pillar one, understanding the integrations that we have between our on-prem environment and cloud, and understanding that we need to secure and limit those integrations and connectivity because threat actors do abuse and leverage those integrations to compromise either your on-prem or cloud. Two is securing and segmenting your identities. Accounts are not created equal. We have privileged and non-privileged. So should the security enforcement you have on those accounts. Going back to the point of maybe if we can enforce FIDO across the entire organization, let's just focus on privileged and high-value users first. And three, around attack surface. Every organization should have the high ground compared to a threat actor where they should know and understand their infrastructure as well as their identities better than a threat actor. That's not always the case from our IR experience. But saying that, and because of that, we recommend expanding your attack surface beyond just network. You should encompass identity. You should identify and understand what a low privilege user can view, can enumerate across your infrastructure. Throughout this session, we presented incidents in a linear fashion. Incidents are not linear. They're dynamic in nature and touch on so many layers, not only from an infrastructure perspective, but also from as part of your organization. And because of that, every organization should ensure that their security programs and initiatives comprehensively encompass the on-prem, the cloud, and every integration in between. And with that, thank you, folks. We have 6 minutes, so I think we can take 1 or 2 questions, and then we'll step outside to take any additional questions. Awesome. Thank you, folks. Hope you all enjoyed. Yeah, sorry. Go ahead.
So can you hear me?
Yeah.
So with respect to the last IR case study, the service account with project owner permissions created, was there a misconfiguration there?
Probably the main misconfiguration was exposing it to a public code repository. That plus having over permissive roles attached to it, it probably didn't require to have that owner permission, scoping it down to only what's required to it.
So from a big picture perspective, I get the impression that a lot of your clients are doing things wrong. That seems to be the lesson learned over and over and over again. So why is that? Do they not have security personnel or IT personnel they're understaffed? What is the problem there?
Yeah, I think, at least from my perspective, and we'll feel free to chime in, but I think it's a common thing that we see across the cloud, right? There's so many benefits when it comes to cloud where you're able to scale up very fast. That ability, you don't get it on-prem, but as part of the price you pay as part of that scaling up is really that it's much, much easier to create service accounts. It's much, much easier to create a bunch of highly privileged accounts and even attach highly permissive roles to those service accounts. And because of that, we see a lot of organizations fall into the mistake of creating accounts, creating service accounts that are highly permissive for the sake of kind of to run the business and support the business and support the IT team, but no one actually goes back, audit those, reviews those, removes the permissions afterward, etc. Will, anything to add?
No, I think that covers it.
Please, we have a question here.
I can shout it. I don't know if there's people online.
I think it's streamed.
Thanks. And you talked about something that's always worried me, but my security guys tell me it's not such a, the big thing, which is the cloud and the on-prem AAD integration. So if we are in a situation where we've kind of combined the two because we've done some legacy transitions for all sorts of very business reasons, is it easy to remove the AD from your cloud once you've got it there?
So the way to look at it is it's not going to be easy. It's going to be very painful, difficult if you want to cut it off completely, especially like looking at it from perspective of on-prem AD integrated with GCP or AWS. For Azure, it's a different discussion, just that because like you need it to be integrated to some extent for some of the services to run, etc. But let's look at it from an AWS and GCP perspective. If you need that integration and you've kind of the business is running, an operation is running because of that integration, that's fine. But at a bare minimum, the highly permissive roles across those cloud service providers, such as administrator in AWS, such as accounts with basic roles in GCP, let's make sure that those accounts are local accounts in their respective cloud provider. And then also we're enforcing that kind of phishing resistant MFA method across those accounts. Well,
Yeah, I think also that the kind of weak point in a lot of cloud environments is the on-prem Active Directory. And so I think a lot of the common themes here is that it's not necessarily just a compromise that has to do with cloud in isolation, but very often there's an on-premise Active Directory or identity provider that's involved as well. So kind of understanding how an attacker might be able to move between those.
Thanks.
any additional questions? Awesome. Thank you, folks. Enjoy the rest of your day.